Hello, in this video I'm going to talk about Angular change detection. When you have an Angular app running, a lot of things can happen. You can click a button, mouse over something, a hover text being displayed. Your app may get some data from a remote server, a database, or an observable emits a new value that is displayed on your screen. All these things can trigger change detection. The change detection will compare all the values on your screen, basically your template, and to check the bindings and then see if anything has changed. If there's a change, it will repaint your screen, refresh the screen. Each component has its own change detection cycles and change detection strategy, and this change detection is being run very, very frequently. So this is a very kind of expensive, they add up. That's why Angular has two different change detection strategies and also offers an array of tools to manage change detection. One common problem encountered in Angular app is either the app fails to run change detection. Something changed, but the app thought nothing changed, so it did not even run the change detection cycle. Or your app ran change detection cycle, but it did not detect the changes, and hence it did not update your screen, which causes your screen fail to update, which is a problem. So I will give a very quick overview of these tools, how you can manage your app's change detection and update your screen. First, let's talk about this process. Your Angular, hypothetically use a browser, say the Chrome. Something happened, the Angular app will run change detection, they found some changes, and the Chrome will tell the CPU, hey, I need to repaint my screen. The CPU sends instructions to the graphic driver and then to video card to display driver to your monitor. Your monitor refreshes, something happens. So that's how things are done. But sometimes there are problems. There are a lot of change detection that is running so fast. There's so many UI artifacts being generated, your screen will freeze. Other times, something changed, but Angular doesn't know it has changed, and your screen failed to update. So next, I'm going to talk about change detection strategies. There are two strategies, the default and on push. Under the default strategy, Angular will run the change detection much more frequently, many times. A lot more things can trigger change detection under the default strategy. For on push, change detections are triggered much less frequently. And also, the default change strategy follows the kind of tree shaking. It will check every component, from your app component to its children, grandchildren, so on and so forth, the whole tree structure. But on push, unless something triggers your parents or grandparents, usually it checks only himself and his descendants. It does not check the components globally. So, in summary, the default change strategy is more expensive. It runs a lot more change detection cycles and check a lot more things and are triggered very easily. But on push, they are triggered much less frequently and they check a lot of fewer things. So if you know your component, like this top bar component, it's static. It does not accept data from external sources. There's no observable emitting values, so on and so forth. It's fairly static and it has a lot of artifacts. Then you can use on push change detection strategy to save some CPU cycles. For most components, I strongly recommend that you use the default change detection strategy because the components are usually very small and wasting a few CPU cycles is not a big deal. The big deal is when your app fails to update your UI, the screen failed to update. That's going to be a problem. So the default is expensive, but it's safer. You can use this ng-do-check lifecycle hook to log change detection. Whenever a change detection cycle is run, you can use this lifecycle hook to log some information, like change detection for component top bar has been run. Change detection for my component home page has been run, so on and so forth. Yeah. Okay, next I'm going to show some tips to proactively manage your change detection. So one is to disable your change detection. For example, you have a for loop here. You load a huge chunk of data from database, an array of data. For each data element, you need to create a form group, and you are very quickly in a loop creating 50 form groups. And when this happens, your CPU is so busy that it cannot paint your screen. And so here you can just use change detection ref detach to disable change detection. After all the forms are loaded, you can use change detection reattach to re-enable change detection. This will save all the change detection cycles because the forms are being created on the fly so quickly. Even if change detection is enabled and people can see it, it does not make any sense because your screen just flickers. Yeah, so that's why you want to, when you have a heavy job, a loop or something to create a lot of UI artifacts, you can disable change detection. When it finishes, you can re-enable it to save some CPU cycles. For another problem, change detection fails to run, or even though the change detection runs, the UI fails to update. Because change detection failed to detect the changes, you can use 5 strategies to force change detection to update your screen. One is invoke mark4check method in a parent component. So in a parent component, you obviously can have a view child. You can access your child component's change detection, and then you can use this whenever you click a button, add some new value, you know something has changed. That will impact the child component, but the child component fails to detect the change. You can just use child components dot change detection ref and then mark4check, which means in the next change detection cycle, please run change detection. So this mark4check is for next change detection cycle because the change detection runs from parents to children. This is triggered in the parent component. When the children's change detection cycle is invoked, the code will be run. Yeah, it will detect changes. Now the child component equivalent is detect changes. So this is when the change is triggered in the child component, but the child component itself fails to detect the changes, and this will force the change detection to run. So Angular will compare the values and see if any values used by your template on the screen has changed, then it will refresh. Yeah. You can also use a dummy input variable, the @input decorator, in your component, so you can receive data from your parent's component. You can create a dummy input, say v is value. This v is just 0, 1, 2, 3, 4. Every time something happens, you can increment that v by 1. So when the value increases, even if the child component does not use this value at all, it's just a useless input, it will regardless update your screen. So this is an Angular behavior. Whenever something changes in the input, the component will run the change detection and repaint to your screen. Yeah. And another strategy is to create a new object reference, because when Angular checks for changes, if the object is a complex object with a hierarchy, like a friend object has a name and a message, 2 properties, it only checks for object reference. If the friend's name has changed or friend's message has changed, the change detection will fail. So you can just assign a new object to your reference. Yeah. Create an empty object, then reassign the previous value to the new object. Then change detection will be triggered because the object reference has changed. The last strategy is just reconstruct your child component. Say you're loading some data from a remote server. This data will impact your child component. You can just, whenever before the data starts to be loaded, you can just destroy the child component. You can have a @if structure in your template, @if display child equals false. Whenever the display child equals false, the child component gets destroyed. And you wait for the data to load. Once you finish loading the data, you can just set display child equals true. Then your child component will be reconstructed from scratch. Guarantee that the change has been reflected. So these are the 5 change detection strategies. I will show you one by one. Feel free to clone this project and check out the code. Okay, I will show some examples here. So here we have a parent component. It has an object called a friend. The friend has a message property and name property. Whenever I click this button, the message will toggle between hello and world. Hello, world, world, hello. So this is how you toggle this value. The default change detection will be able to see the changes. So when you click on this toggle in the parent component, the child component that this friend is injecting to the child component using the input, it will refresh. But this is not the case for on-push change detection strategies. I will show you some source code first. Here's the child1 component. It has an input called friend. It uses default change detection strategy, so it has no problem picking up the change from the parent. Child2 is different. Its change detection strategy is on push. So when the parent changes, it fails to capture that change. Even though the underlying value has changed, here underlying value has changed, but in child component 2, it always displays the initial value. It does not update. Here in the parent component, I have a method called mark4check. It will toggle this message part of the friend. If it's hello, it changes to world. If it's world, it changes to hello. But at the same time, it will grab the child2 component and use this mark4check method. This mark4check method tells child component 2, hey, when the next change detection cycle comes, make sure you check for changes. Now let's get back to the browser. So mark4check, this button triggers the method. When you click on this button, hello, word, word, hello, they are synced. They always change together because the parents tells the child component to check for changes. In child component 2, I also have a method called force change detection. So this method is a bit complicated. It does a number of things. It will use an observable called countdown. This observable will emit values. I mentioned that when an observable emits value and that value is displayed or consumed by your template, it will trigger change detection. And at the end of 15 seconds, it will trigger change detection by force, detect changes. So it will trigger change detection multiple times. Whenever a new value is emitted, change detection triggers. At the end of 15 seconds, it forces change detection to trigger. So let's now look at the screen. So here we have this method. If we click on this button, so see here, hello and word are not the same. When I mouse over, the word becomes word, hello becomes word. They are synced because the mouse over event with a tooltip, this detect change after 20 seconds. This tooltip itself will trigger change detection. Now let's click on this button. Hello, word, word, hello not synced. Wait for a few seconds. Now the hello, hello, they're synced. Now again not synced because click the button. Let's wait for the next value. Wait a few seconds. Oh, they're synced now. Yeah, let's just change that to unsynced again. I'll wait for just a few more seconds. At the end of 15 seconds, the detect change function will be invoked and they will be synced again. Just wait, 15 seconds, yes. So basically, I'm trying to show you is that you can change detection by mouse over something. Oh, hello, it's synced. So you can see, you can trigger change detection by mouse over with a tooltip. You can trigger change detection by emitting values from an observable. That value, if that value is displayed on the screen, it will trigger change detection. Or you can, at the end of the 15 seconds, you can trigger that detect change method. These will all trigger change detection. Now let's look at the parent component again. This method reset reference. So it creates an object called old friend that refers to the original friend value. Then it creates this friend. It points to a blank object. This changes the reference of this property friend. You reassign a new object to this friend property. Then you assign the value from your old friend, previous value, back into the new object. Because the object reference has changed, the change detection will be triggered. So if you want to force change detection to trigger, you can just create an empty object, assign the old value to your new object. The change detection will be forced. Okay, let's take a look at the screen. This is the guy. Reset a friend to a new object. So hello, word, they're not aligned. Word and hello. Reset to a new object. Aligned right away. So this is another method to force change detection. When you assign this object friend to an empty object, then repopulate it with original value, it will trigger change detection. The next method to trigger change detection is to use a dummy input value. If you look at child component 3, it has two inputs. One is the friend, which is it grabs from its parents and display it. A second input is called v, its number equals 0. Every time the parent invokes this, increment this value plus 1. And when this input value changes, even though this input value is not used in anywhere, so the child 3 get this v value, but it does not use it at all. There's no v in the template. It's a dummy, useless input. But whenever the parent increments this input by 1, the child will refresh the screen. We will trigger change detection. So increment by 1. So you can see here, word and hello, they are okay. This child 3, yeah. Word and hello, they are not aligned. But if I increment the value by 1, they're aligned. So hello, word, increment by 1, they are aligned. So if you have input value, even if that input value is not used anywhere, it will trigger change detection if that input value changes. So let's talk about the last method. The last method is basically reconstruct your child component. In your template, you can use @if statement and to create a local variable called displayChild. And you can set the displayChild to true, then the child component will be displayed. You set it to false, the child component will be destroyed. If you anticipate some change will happen, you can destroy the child component, set displayChild to false. After the change has happened, you can just set the displayChild to true. The component will be reconstructed from scratch. So this does not rely on Angular's change detection strategy, but it will guarantee that you get the updated screen. Okay, thank you for watching. Bye.